we had left off, I believe in your class after A, right?
Yeah.
We had left off, we had changed 90 degrees and came up with it is equivalent to pi over 2 radians. Okay, thoughts on 250 degrees? What are we going to do with 250 degrees to get it into radians? Okay, in order to go from degrees to radians, we're going to multiply by pi over 180. Okay, we're putting the 180 degrees on bottom to get it to cancel out. We're trying to get into radians. Now, in this one, okay, you can go ahead and multiply it into one fraction if you want. However, think cross-canceling. What do you know about 250 and 180?
We could divide them by 100.
Not 100, but...
Oh, so something to make it 25.
Okay, so since they both end in zeros, in elementary you just learned off your marking off the zeros. It's dividing by 10 is what it's doing. Okay, so if we do that, on top, I'm going to have 25 times pi. On bottom, 1 times 18, which is 18. Does 25 18ths, if you ignore the pi, does 25 18ths reduce, simplify? No. And we're going to leave them improper, and this would be how you would leave a radian answer. So 25 pi over 18 radians. Okay? And it's not that you necessarily have to label radians. If there's no label, we still know it's radians. Okay, C. How many degrees are in pi over 3 radians? What are we going to do here?
We're going to reverse.
Okay, we're going to reverse. So we're going to take pi over 3. And we're trying to get it to degrees, which means in order to go degrees, we're going to multiply by 180 degrees over pi. What, of course, is the design here? Okay, your pi's cancel. You can go ahead and multiply, or my brain cross cancels. What do you know about 180 and 3?
60.
They both divide by 3. 3 divided by 3 is 1. 180 divided by 3 is 60. So we end up with what? 60 over 1, which is just 60 degrees. Okay. That's a common one that you'll just know eventually after we work with it more. If you glance over there at the unit circle, so I wrote on there because that unit circle doesn't say, but 0 is at what we would call 3 o'clock if I need to give a location. And when you go around the unit circle, you're going counterclockwise. So notice if you go up from 0 to pi over 3, does that look like a 60-degree angle? Okay. So you're going there at 3 o'clock up to, what is that, about 1 o'clock or so? Okay. So just to kind of orient you a little bit there. Okay, D. How many degrees are in 5 pi over 18 radians? What do we do?
Multiply it by 180.
Okay. It's 5 pi over 18. We're trying to go to degrees, which means I'm going to multiply by 180 degrees over pi. Of course, what happens here?
Take the pi.
The pi's definitely cancel.
And then,
Do you see the other canceling?
18 and 180.
18 and 180 would both divide by 18 if you want. 18 divided by 1 is 18, or 1. 180 divided by 18 is 10. Don't worry, I'm having struggles too. So if you do all that cross-canceling, what's left?
5 times 10.
5 times 10, which is
50.
50 degrees. Okay. And you can do some of this on the calculator. Don't get me wrong. Okay. We've got to know our fraction skills. Okay. There's not always a calculator option.
But there will be on this one.
Yes, you will have calculator option on your test. Okay, E. Convert 25.5 degrees to radians. So what am I doing here?
25.5 over 1 times 180 over. Wait, nope. Times pi over.
Okay. We switched back, didn't we? Watch your directions. They're going to mix and match for you. So 25.5 degrees over 1 times pi over 180. Now, we have a decimal here, don't we? I think for this one, to get us started, I'm just going to go ahead and put this as one fraction. Okay? If I put this as one fraction as is, 25.5 times pi, I can rewrite as 25.5 pi over 1 times 180 is 180. Now, do we leave an answer like this typically? No. Pi is good in there, but the decimal in there is not great. Okay, what are options for getting rid of a decimal when we're in that fraction form?
Multiply 5 by 0.5. So, reciprocal.
What would cause my decimal to move one spot over? What could I multiply by? 10? Because what does multiplying something by 10 do? It adds a 0, or if there's a decimal, it moves it over 1. So an option, and I'm not going to say it's the only option, but we can multiply by 10. If I multiply the top by 10 to get rid of that decimal, then we need to multiply the bottom by 10. So 25.5 pi times 10. Well, just worry about 25.5 times 10 is going to be 255 pi over 180 times 10. 1800?
Is that your answer?
No.
I don't like that.
I don't like that answer either. It would not be where I'd leave my final answer. And here's the deal. Ignoring the pi, 255 and 1800 end in 5 and 0. If numbers end in 5 and 0, I know I can at least divide by 5. Maybe something bigger.
You think so?
I do think there's something bigger. I don't know what off the top of my head. No, I'm not sure.
Hold on.
What do you get if you divide by 5?
255 divided by 5 is 51.
And what's 1800 divided by 5?
2 divided by 5 is 51.
Oh, I did 225.
Okay. 51 over 360. 51 pi over 360.
So this is a good. So 51 over 360. Well, I know it reduces more, but I know something about 51 that's probably not coming to your brain. So I know a multiplication fact set of 51.
Do you?
I do.
That's mighty cool. I don't. I'm lost. Oh, is it 85? What?
51 divided by 85.
255 divided by 85 is 3.
So I personally know that 51 is divisible by 3. Because 51 is 3 times 17. That's a math fact that I know. Do you necessarily know that fact? No. Now, how confident are you guys with these calculators? I always hesitate to show this tip, but
Oh, it's not 85.
these calculators will simplify fractions, folks.
Oh,
You have to put it in a fraction form for it to do it,
that is
but it will simplify the fraction.
15.
Okay, so 255 and 100, or 255 and 1800 could divide by 5 and by 3. So they could have divided by 15 each, or they could have divided by 5 and then by 3. However, backup plan, if you get to that point, you're like 51 over 360. I think it's good. Well, here's an option. If I put 51 over 360, guess what? It just reduced it more for me, didn't it? Okay, am I doing something wrong or is my answer key wrong?
Oh.
Is it 20 or 200 on bottom?
120. I got 120.
Or 120?
Yeah. 120.
Okay, so I just left the 1 out in mine. I have 17 pi over 20, which is why I'm thoroughly confused at this exact moment. But I just left the 1 out, you know. Okay, so one way or another, can you get yourselves to 17 pi over, start to do it, 17 pi over 120. Can you get there?
Yeah.
Okay.
Oh, I'm there.
One more.
I did it right.
Convert 2.5 radians to degrees. What are we doing here? Multiplying by 180 over pi?
It's okay.
Okay, so this one's a little bit different because if you're converting 2.5 radians, radian measurements normally have a pi already in them that cancels out, don't they? It doesn't happen this time, okay? If you go ahead and just multiply across, 2.5 times 180 is 450. And so at that point, we have 450 over pi. Is that how we normally express a degree answer? No. So you should go, this is degrees, you should go one more step. What is 450 divided by pi? Yeah, I have 2 decimal places. So I have 143.24. Is that the rounding right?
Yeah. What are we? Oh, degree.
And that is degrees. Okay, so be smart about the problems. Okay, radians, yes, you should have pi's in their answers. On occasion, there's not a pi in the radian answer. Okay, degrees, you don't leave a pi in there. You go ahead and make it the decimal. Yes?
Will we have this on the test?
Like the conversion factors?
Yeah.
That will be up to you. And I will make more sense. In other words, yes, you can. I will make more sense of that later on in the chapter.
Okay.
But I do not provide a formula page in this chapter. You essentially get to make your own. And I'll give more details about that because what it is it has to do with the unit circle. Okay? So I provide you a copy of the unit circle, and that is your page of notes that you are allowed to add appropriate things on. Okay? You can't just add in worked out problems or anything, but appropriate tips. So I'll explain that later on.
Okay.
Okay, on the back side, we have a formula here to be familiar with, and this is the arc length formula. So, definition though, a central angle is the angle made at the center of the circle. So, okay, there is my supposed circle. A central angle is the idea, I don't feel like that center is at the center of the circle. The central angle is the idea that right there, that's a central angle. It's an angle made at the center of the circle. Okay? When we talk about arc length, the arc length S is the length of the curved partition of the circle. So, based on this angle that I just called theta, S is this curved partition of the circle. That is the arc length. Okay, so the arc length formula is based on knowing the measure of the angle, theta, and then also r, which is the radius of the circle. So arc length formula S equals r theta, where S stands for arc length, r is the radius, and theta is the angle, catch this, in radian form. In other words, can theta be in degrees? No, your formula doesn't work right. Theta is in radian form. Okay, so be aware. So that is the arc length formula. It will come up in various problems. It comes up in word problems. But if you're trying to find the length of the curve of the circle, that is your arc length. Let's try an example. Okay. So this example. Find the perimeter of a 60-degree slice of a large 7-inch radius pizza. Okay. So what's this picture showing? This picture is the piece of pizza. Because what's the idea? There's the whole pizza, right?
Such a good circle.
Until the very end, it wasn't bad. So I'll take it. It's better than most, right? Okay. But what are we trying to find? We're trying to find the perimeter of this piece here. Okay. It says it's a 60-degree slice. So what is that 60 degrees? That's that central angle right there. So it's a 60-degree slice, means that's going from the center out of a large 7-inch radius pizza. Well, your radius goes from center to the edge, so that's already labeled, yes? Each of my radiuses are 7. And then they have this outside edge labeled as S, because what is it? It's the arc length. Okay, now, perimeter. How do we do perimeter?
Add all the sides together.
Add all the sides together. So, what do we know?
7. R is equal to 7.
There's 7. What else do we know?
That, 60 degrees. 60 degrees. Wait, so ours.
Okay, hold on. It's not going well. I'm just talking perimeter for a moment. What do we need? What are the pieces that we're going to add up? Or how do we find perimeter, I think, is where I started.
7 plus 7 plus S.
Okay, you're adding up all the sides, yes? Okay, and so when we're adding up all the sides to the pizza, then what Katie said, 7 plus S? But do we know S?
No.
Can we find S?
Yes.
Yes. How are we going to find S?
R times.
We're going to use that arc length formula of R times theta. R is 7. Theta is? We need to find it? It's not 60?
No, because that's being radiant.
Okay. So theta kind of is 60, but it's 60 degrees, and we need it in radian form. So side note, how do you take 60 degrees and change it to radians?
Pi over 1.
We multiply by pi over 180 degrees, what we were just doing on the front side, yes? Do some math. 60 and 180 cross cancel in my brain. 60 divided by 60 is 1. 180 divided by 60 is 3. So I end up with pi over 3 radians. So what's that mean?
Your baby is equal to pi.
Okay, my theta is going to be pi over 3 because it by definition of the formula, it has to be in radian form. Okay, so find S. What would you say 7 times pi over 3 is?
7 pi over 3.
My brain goes to 7 pi over 3. However, ultimately, what are we going to be doing in this scenario?
Adding it. You think 7 and 7.
Yeah, we're going to be adding it to 7, 7. We're going to be finding a perimeter. Is 7 pi over 3 the form you think you would be expected to leave it in?
No.
No, I would probably go for a decimal form.
7.33.
Okay, so grab the calculator. You said 7.33?
Yes.
Okay. So now, am I done with 7.33? No, because officially my directions were to find the perimeter. The perimeter of the slice of the pizza, if you think of the pizza having three sides, straight edge 7 plus straight edge 7 plus curved edge 7.33 gives me an approximate perimeter of 21.33 inches.
That was okay, I guess.
Okay. Arc length formula is one we've got to know. It pops up here and there. It'll pop up some in homework. Okay. Shall we talk track? The running lanes at the Emory Sears track at Bluffton College are 1 meter wide. The inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? Okay. How this problem is worded and how the picture shows don't exactly go together in my mind, because they show this picture here, which I'm not a track person, but this to me says 2 turns, because there's 4 turns on a track. And I feel like this is going around one end of a track, but this is the picture they provided, so we're going with it. Okay? So we want to know how much longer is lane 2 than lane 1 around one turn.
So you're saying this is 2 turns?
Well,
Okay.
this picture.
So one.
The wording says 1 turn. The wording says this is 1 turn. I feel like it's 2 turns, but
That's okay.
because don't track you have turn 1, 2, 3, and 4.
Normally it's just the curve and the straightaway.
Oh, okay.
The curves and the straightaways.
Turns and
There's 2
straightaways.
curves
Okay.
and 2 straightaways.
Okay, well, so maybe this is 1 turn then. This is our picture, though. This is what 1 turn is. Got it?
Got it.
Okay. So are you seeing? And then when they say the inside radius of lane 1 is 33 meters, they're saying if you think of this as a circle, right? This is a part of a circle. So here's the center of your circle. From the center of the circle over to the inside of lane 1 is 33 meters. And this is saying 34, so this is saying from the center of the circle to the inside of lane 2 is 34 meters. Does that make sense to you? That's the information they're giving. And they also stated that each lane is 1 meter wide. Well, that makes sense that there's a difference of 1 meter in those measurements. Okay. How much longer is lane 2 than lane 1? Do you see what we're going to be finding here?
I think R is equal to 34 and 33.
Okay. Our radiuses are 33 and 34. And what we're comparing is how much, so when we talk about lane 2, you assume that they're running on the inside. How much longer is lane 2 than lane 1? Does that make sense?
Yes.
Okay, so how much that person has to stay, if they have to stay in their lane, how much farther is that person running than the person in lane 1? Okay, so are we seeing this as arc length? Okay, because those lines I just drew in, those are arcs, yes? So those are my arc length. Katie mentioned that my radiuses are 33 and 34. What am I missing? The angle. 180. Because here's the idea, guys. Here's the center of my circle. If we're going from starting point here to ending point here, whoops, what is that angle? Do you see it? that is 180 degrees. Or what is 180 degrees the same as?
Half a circle?
Okay.
Correct.
What am I going to need for my formula? Can I use 180 degrees in my formula?
2 pi. 2 over pi.
So 180 degrees, if we convert that to radians, 180 degrees, when you convert that to radians, what are you multiplying by?
1 pi.
Pi over 180. So 180 degrees is equal to
Pi is 180.
pi. Remember, pi is 180. Eventually, that will just be common knowledge, and you won't imagine not knowing that. Right now, that's still a stretch. Okay? And I know it was in the afternoon class, I put 0 over there at 3 o'clock. In the unit circle, you counterclockwise, it's backwards. But if you go 0, if you go 3 o'clock, you go backwards over to 9 o'clock. Where do you land at? You land at pi. That's also 180 degrees. Okay, so let's talk lane 1. Lane 1. S equals r theta. I need that arc length. So in lane 1, r is 33, and theta is, what's that angle? Pi. 180 degrees, but it's pi. What is 33 times pi?
33 pi.
33 pi. And we're not going to leave our answers in pi, but that's easy for right now. Okay. What about lane 2? Again, think S equals r theta. What's your radius on lane 2? 34. What's my theta? What's my angle? Pi. What's 34 times pi? 34 pi. How much longer is lane 2 than lane 1 around one turn? Because what do? You're going to subtract, yes? Lane 2 minus lane 1. So what is 34 pi minus 33 pi? And that is 1 pi. What do you guys know about pi?
3.14.
3.14. So when I'm not going to say my answer is pi because that's not, you don't say that a turn is pi longer. It's 3.14 what? Meters. Okay. So another use of our pi or our arc length formula. Okay. We need to spend a little time with angular and linear motion. Okay. I talked yesterday with doing conversions where we did fractions, right? Where I said, okay, 1 degree is 60 minutes. You can cancel labels, right? We're going to use that seriously here. But so angular speed, which can be measured in something such as revolutions per minute or RPMs. You might have a dial on your car dashboard that says RPMs. Okay? So angular speed can be measured in units such as revolutions per minute. And what we're going to talk about is it can be changed to linear speed. Linear speed is what you more normally think of, such as miles per hour, feet per minute, so on and so forth. By conversion factors, like what we use to change radians to degrees. Now, before we continue, key point here. This is going to be, most of the other connections will make sense to you. This one's a little fact I have to throw in. You're gonna, if I say inches to feet, you're going to be able to come up with that information, right? Basics. But the one that we're going to have to be aware of, the connection is usually, in general, provided by a conversion factor that equates the fact that 1 radian. So a unit of 1 radian of angular measure is equal to 1 radius of the arc length. So in other words, what you need to realize here is 1 radian is going to equal whatever 1 radius is in that problem. Okay, obviously the radius changes from problem to problem, yes? But what you need to be aware of is that 1 radian of measure is going to equal 1 of whatever the radius is. Okay? Now, tuck that in your mind, and let's talk about Albert. Okay? Albert's truck has wheels 36 inches in diameter. If the wheels are rotating at 630 RPMs, rotations per minute, find the truck's speed in miles per hour. So, now, it used the word rotations per minute. Up above it said revolutions per minute. Are you okay if I say a rotation and a revolution are the same thing? Okay. A rotation, a revolution. Same thing. So I know this problem says rotations. You can also think revolutions. Okay, so what do we know? We are starting with the information that his wheels are rotating at 630 RPM, which is rotations or revolutions per how often? Minute. What are we supposed to get to? My goal is to get to miles per hour. That's my end goal.
This is like.
It is. Okay.
I don't think you understand. I failed.
Okay, so ultimately, revolutions is on top. It needs to magically turn into miles. We're going to use our conversion factors here. Minutes is on bottom. It needs to turn into hours. Okay? Those are the links we're going with. So, 630 revolutions, I'm going to say this is per 1 minute. Now, what other information did they provide us? The only other information they provided us is that these wheels are 36 inches in diameter. If you know the diameter, what else do you know? The radius. What is the radius?
18.
Okay, I'm just going to write it down here so I have it. The radius is 18 inches. Okay. You want to get the easy one out of the way?
Minutes to hours?
Can we do minutes to hours? What do you know about minutes and hours? 1 hour is equal to 60 minutes. Now, okay, review. You can either make it 1 hour over 60 minutes or 60 minutes over 1 hour. Our goal is we want this label to cancel. So if I want minutes to cancel, what's that mean? 60 minutes on top over 1 hour on bottom. Does that sound familiar?
Yes.
I don't know how Doc teaches it versus how I teach it, but it's the same idea. Okay? Because now, if we stop here and multiply and divide everything, I currently am going to be at revolutions per hour. Now, good news is, I'm halfway there in my labels. We have hours, yes? Now, we've done the shorter part of the halfway, but, okay. Revolutions. Okay, we need to get out of revolutions. A revolution is? Revolution is once around a circle, yes?
Yeah.
What measurement do you know about once around a circle? Okay, it's 360 degrees. What do we know about 360 degrees? It's how many radians?
2.
2?
2.
Now, what? Here, oh, it's up on the previous screen. What was 180 degrees?
Pi.
Pi. So 360 is double that, yes? Or if you glance there at the unit circle, if you start at 0 and you go all the way around, what's the other label for 0? 2 pi. Okay? So what I'm going to say here is I'm going to equate that 1 revolution around the unit circle is equivalent to 2 pi radians. Now, I can do 1 revolution over 2 pi radians or 2 pi radians over 1 revolution. Well, what do we want to happen? Revolution is on top. We want revolution to cancel. So 1 revolution on bottom is equivalent to 2 pi radians on top. Okay, that's a new one, right? But revolutions cancel. If I stop right now, I'm on radians per hour. Now, radians per hour.
See it. 1 radian is equal to 1 radius, and the radius is equal to 18 inches.
What she said?
Yeah. And then you can go from inches to miles, right?
Okay, so I'm in radians. This is our connection link here. A unit of 1 radian is always going to be equal to 1 of whatever the radius is. What is our radius? 18 inches. Our radius is 18 inches. So 1 radian is equal to 18 inches. Now, you want 1 radian over 18 inches or 18 inches over 1 radian?
18 inches.
18 inches over 1 radian because
We want to cancel radians.
I'm canceling radians. And radians was on top. Yes? Okay. Now I'm at, if I stop now, I'm at inches per hour. What's my goal? Miles. This is where you should be able to pick up and take off. What do you know about inches? Go for the small step.
The feet. Inches to feet.
Inches to feet. 12 inches and 1 foot. 12 over 1 or 1 over 12?
1 over 12.
1 foot over 12 inches because inches cancel. Now if I stop now, I'm at feet per hour. And now everyone gets stuck again.
Is it? It's not 1800, is it?
Nope. What do we know about feet and mile? Or what are you supposed to know?
560.
No.
That was my close.
Not really. 1 mile. 1 mile is 5,280 feet.
Holy crap! Is it
I
really?
just have that in my brain.
5280. I
Sure.
did at one point in Kim. But
Okay, now, what do you want on top? We want feet to cancel, so 1 mile over 5,280 feet. Now, are we there?
Yeah. We gotta do the calculator.
Okay, feet cancel? Feet cancel? We're left with miles. Okay, we're there. Practice putting this in your calculator. I cannot stress that enough. My recommendation is you do a fraction bar. Multiply everything on top of the fraction bar. So 630 times 60 times 2 times pi
I wrote 360.
times 18. And then in my denominator, I don't have to write all the ones, do I? But I can say 12 times 5280. Here's what I'm going to say. If your answer's right, it matches mine. If not, you did something wrong in the calculator. Approximately 67.47 miles per hour. This one's going to take work, guys. Okay, this is the extra hard part of this lesson. It takes work. You're going to have to work on it. But this is the idea.
45, 50, and 51.
It's 1 or 2 of them. There's not a lot of it. Maybe 2 of them, I'm thinking. So, But yes, it is in the 45, 50, 51 area. Okay, real quick. I know I'm almost out of time, but good news. This is a much easier. Okay, the other relationship we're being told, nautical miles. Nautical miles, the length of 1 minute of arc along the Earth's equator. A statute mile is what we know of as our familiar land mile. Hey, guess what? It was right here in front of you the whole time. You didn't realize it. Okay?
Oh my goodness.
I didn't remember it either. So, now the conversions are provided here. 1 statute mile is approximately 0.87 nautical miles, or 1 nautical is approximately 1.15 statute miles. Either or will work. Now, real quick. Megan flies a distance. I'm trying to hit the highlights. She flies a distance of 2,698 statute miles. Her flight time calculations are based on nautical miles. How many nautical miles is it from Boston to San Francisco? Well, if you're starting with 2,698 statute miles, if you put it over 1, what are options? Make one of these a fraction. Okay? And you can go either way with this. If I just use the top one, 1 statute mile equals 0.87 nautical miles. I'm going to put statute mile on bottom because I want it to cancel. So I'm going to say 0.87 nautical miles over 1 statute mile. And of course, your idea is that your statute miles cancel. And in this case, you're multiplying. 2,698 times 0.87, I have written down as 2347.26 nautical miles. If you use the other conversion and you would have ended up dividing by 1.15, you would get a very similar answer.
Very similar, like you count it right similar?
Yes. Yeah, like it might be off by a decimal or something. Okay, your homework, page 318. 2 through 42 evens, 45, 50, 51. See what you can do with it. Bring back your completed homework and questions tomorrow.